This chapter contains the following components: introduction, statement of the problem, assumption of the study, scope and delimitation, and significance of the study. Introduction. Electricity is a form of energy. This is a flow of electrons and considered as one of the most widely used forms of energy. The application of electricity today are broad, starting from smallest devices to a bigger one. Electricity is now part of our daily lives. Most of the things that surround us are powered by the said form of energy. We get electricity, which is a secondary energy source, from the conversion of other sources of energy like coal, natural gas, oil, nuclear power, and other natural sources, which are called primary sources. Fossil fuel is the most used in producing electricity, but it will take millions of years to form in the earth crust and can never be replaced when they have been used. If we keep using this fuel, they will eventually run out. Oil and gas will be the first to run out, and then coal. When fossil fuels burn, they release carbon dioxide into the atmosphere. Research shows that a major contributor to greenhouse effect and global warming is the overuse and burning of fossil fuels. Coal and gas also release sulfur dioxide gas when they are burned. Sulfur dioxide can cause breathing problems for living creatures and also a major part of acid rain. Through these several disadvantages of using fossil fuels, switching to renewable energy gradually is one of the best solutions. One example of renewable energy is hydroelectric power. Hydroelectric power, also called hydropower, the electricity is produced from generators driven by turbines that convert the potential energy of falling or fast-flowing water into mechanical energy. In the early 21st century, hydroelectric power was the most widely utilized form of renewable energy, and in 2019, it accounted for more than 18% of the world's total power generation capacity. This study aims to promote alternative sources of energy so that the usage of non-renewable resources will be lessened. This also promotes innovation and creativity in producing different devices or machines towards harnessing the potential energy that can be found in surrounding in a safer and a cleaner way. And more importantly, through this proposed device, this can help those small community or those people who don't have access to electricity. The researchers believe that this study will be served as a first step towards a cleaner and a sustainable environment. This research is focused on designing and fabrication of a small hydroelectric generator using Archimedean screw turbine. The researchers made use of Archimedean screw turbine due to its great advantage in low head. It doesn't require the higher elevation to operate. And Archimedean screw turbine is more suitable to put in a source with a higher flow rate. The location for the testing of the said device is located at Zone 3 Nakara San Isidro, Iriga City, where irrigation with a higher flow rate is located, which is suitable for the operation of the proposed device.
Statement of the problem. The aim of this study is to develop a small-scale hydroelectric generator, especially answering the following question. Number 1. What is the appropriate design of a small hydroelectric generator using Archimedean screw turbine? Number 2. What materials, tools, and equipment are needed in fabrication of the proposed device? Number 3. How effective is the small hydroelectric generator using Archimedean screw turbine, punctuality, and reliability? The appropriate design of a small hydroelectric generator using Archimedean screw turbine are, are described as set of spiral planes fastened to a central shaft. The screw is usually housed in a closely fitted enclosure or true. A gap exists between the true and in the planes, allowing for the pre-rotation of the screw. A model can predict the volume of water in each of the buckets, water that entrapped between two helical planes. This together with the length can be used to find the ideal power and efficiency of a screw. The materials and tools are used in fabrication of the proposed device are the following: angle bar, flat bar, metal plane, pillow block, shaft, AC generators, bolt wires. Tools to be used: hacksaw, pliers, and screwdriver. Punctuality and reliability. The punctuality and reliability with the variable flow rates and fixed rotational speed. The second is to completed with the constant flow rate and variable rotational speeds.
Assumption of the study. The design small hydroelectric generator using Archimedean screw turbine can produce electricity. The small hydroelectric generator using Archimedean screw turbine can be fabricated. The model can be functional and reliable. The turbines of the screw harness the water pressure to convert potential energy into mechanical power which drives an electric generator and other machines. The Archimedean screw can be used also as transport water from low-lying areas up to irrigation ditches. A small hydroelectric generator using Archimedean screw turbine are a new form of clean and renewable source of energy and are safer for wildlife. A small hydroelectric generator using Archimedean screw turbine. It can offer many economic, social, and environmental advantages that make them an important option for providing sustainable source of electricity, including in undeveloped, hard-to-access regions and small communities. Scope and limitations. This study is limited to developing a small hydroelectric generator using Archimedean screw turbine. Furthermore, the location or site where the device will be testing is located at Sontri Nakar, San Isidro, Erga City. Small hydroelectric generator using Archimedean screw turbine. Using the use and irrigation in the Nakar, San Isidro, Erga City. It has a big impact to the community to have an own source of electricity power. Using this source of power, they can able to charge their phone or other electronic gadgets and may be used as electric source of lights in their highways or etc. The use of the small hydroelectric generator to renewable source of electricity, it has a big impact to lessen their bills in electricity consumptions and they can still use the money for other expenses.
Definition of terms. Archimedean screw turbine is a helical surface surrounding a central cylindrical shaft, a hollow pipe that is used to carry water to higher elevations. But water in higher elevations can be translated down the length of the screw due to hydrostatic force from fluid on the screw surfaces, resulting to rotation of the screw. Casing. It is the enclosing shell, tube, or any protection that surround the materials. Flow rate is measured in cubic meters per second. It is the volume of water passing a point in a given amount of time. Head is expressed in feet or meters. It is the vertical change in elevation between head water level and the tail water level. Hydroelectric generator. A generator of electric current driven by a hydraulic turbine. Usually, a hydroelectric generator is a salient pole synchronous generator whose rotor is connected to the rotor of a hydraulic turbine. Hydroelectric power, also called hydropower. Electricity produced from generators driven by turbines that convert the potential energy of falling or fast-flowing water into mechanical energy. Potential energy is stored energy that depends upon on the relative position of various parts of a system. The water behind a hydroelectric dam stores gravitational potential energy since it is at a higher level than the water on the other side of the dam. As the water falls, this potential energy is converted into kinetic energy, which turns turbines to generate electricity. Turbine is any of various devices that convert the energy in a stream of fluid into mechanical energy. The conversions is generally accomplished by passing the fluid through a system of stationary passages, or vanes, that alternate with passages consisting of fin-like blades attached to a rotor. by arranging the flow so that a tangential force or torque is exerted on the rotor blades. The rotor turns and work is extracted. Chapter 2. Theoretical and Conceptual Frameworks. This chapter consists of the following parts: the review of related literature and studies, the synthesis of the state of the art, the theoretical framework, and the conceptual framework. Review of related literature and studies. This chapter is a preparation of studies and literature related to the present study. Number 1. Archimedean screw turbine. According to Renewable First, as the name suggests, Archimedean screw turbine came from the acknowledged inventor of the screw, which is Archimedes, back in 250 BC. Historically, they were used in irrigation to lift water to a higher level and were generally powered by oxen, or even humans in smaller versions. When used as a hydroturbine, the principle is the same but acts in reverse. The water enters the screw at the top, and the weight of the water pushes on the helical flights, allowing the water to fall to the lower level and causing the screw to rotate. This rotational energy can then be extracted by an electrical generator connected to the main shaft of the screw. Archimedean screws for hydropower are used on low head or high flow sites. This maximum flow rate through an Archimedean screw is determined by the screw diameter. Number 2. Electric generator. Electric generator, according to Baiju's electric generators, also known as dynamos, is an electric machine that converts mechanical energy into electrical energy. In this study, the mechanical energy that will be provided is through water flow. Electrical generators provide nearly all the power that is required for electric power grids. Number 3. Related studies. The researchers gathered and reviewed several related studies that are relevant and have similarities to the current study and that presented in this section. From Yusuf Dust and Lubitz's study, we took into account that it is very important to have estimation about the volume of water that can pass through the screw for designing. The study modeling the energy extraction from low-velocity stream water by small-scale Archimedes screw turbine by M.D. Lee and P.S. Lee is where we based our model. According to the study investigation of physical and numerical model of Archimedes screw turbine, the power produced using Archimedes turbines depends on some parameters, including number of plates, flow, angle of the shaft inclination, and the length of the pitch. Next, we move on to theoretical framework. This study is guided by the principles or theories of Archimedean screws generator and hydroelectricity as shown in Figure 1. First, I will discuss the theory of Archimedean screw generators. Based on the research of Song-in, water at higher elevations can be translated down the length of the screw due to the hydrostatic forces from the fluid on the screw surfaces. The resulting rotation of the screw drives a generator that creates efficient, cost-effective, and clean electricity. This means that the force caused by the pressure loading of the water flow enables the screws to rotate and drives the generator to create electricity. First, I will discuss the theory of Archimedean screw generators. Based on the research of Song-in, water at higher elevations can be translated down the length of the screw due to the hydrostatic forces from the fluid on the screw surfaces. The resulting rotation of the screw drives a generator that creates efficient, cost-effective, and clean electricity. This means that the force caused by the pressure loading of the water flow enables the screws to rotate and drives the generator to create electricity. Next, I will discuss the theory of hydroelectricity. Hydroelectric power captures the energy released from falling water. In the most simplistic terms, water falls due to gravity, which causes kinetic energy to be converted into mechanical energy, which in turn can be converted into a usable form of electrical energy.
Regarding the topic of conceptual framework, the conceptual framework of the study is shown in Figure 2 that serves as an illustration representation that indicates input, process, and output. This serves as a guide for the researchers in making of this study from the first step until to the construction and performance evaluation of the research model. The input includes the different principles and concepts that researchers used upon the designing and construction of the device. Through the informations and concepts that gathered, it serves as guides in selecting and considering materials, tools, components, and machines needed to make this device. The throughput involves the planning of the device and material to be used, deciding on how the device will operate, fabrication, preliminary test, and evaluation to improve the functionality of the device. The output, wherein it is a device that generates electricity through flowing water. The efficiency, evolution, and feedback loop define the process of monitoring the effective functionality. Figure 2. Conceptual paradigm. Input contains principles and concepts, tools, materials, and equipment. Related literature and studies. Information reference. In the process, here are the planning, designing, fabrication, and testing. And the output is the small-scale hydroelectric generator and innovation. Chapter 3. Materials and Methods. This chapter shows the methods and procedures that will be used in conducting this proposed study. This includes materials, equipments needed, and other necessary procedures in constructing the proposed device that will convert the potential energy coming from flowing water to electricity by using Archimedean screw turbine and generator. These include planning, designing, fabrication, and testing. Research method. The researchers will be using development method of research to construct an improved device that converts the potential energy coming from flowing water into electricity. In order to obtain with an efficient and effective design of the said device, a detailed planning procedure is needed. So, researchers are properly planning and designing to be able to come up and gather different ideas and achieve the proposed design. Material and equipment list. In the tables showed below are the list of raw materials and equipments that will be used in constructing the proposed device. Table 1. List of raw materials. Angle bar, flat bar, metal plate, pillow block, shaft, AC generators, bolts, and wires. In Table 2, list of tools and equipment in fabrication. In tools, hacksaw, plies, screwdriver. Equipment, welding machine, angle grinder, and electric hand drill.
Research procedure. The researchers will follow a step-by-step procedure to properly construct and enhance the functionality of the proposed device. The research procedure of this study includes planning, designing, fabrication, and testing of the proposed device. Number 1. Planning. The researchers will start to gather data in accordance with the topic. The sources of data can be through online articles, past research, books, documents, videos, and other means of sources of data. The location where the device will be testing will also inspect and analyze its sustainability to run the proposed device. Collecting data like rainfall data forecast, weather condition, and other useful data in accordance to the location sustainability are also considered. Number 2. Designing. Upon analyzing the gathered information and ideas, the researchers will now start in designing the needed components of the proposed device. Several factors will be considered in the designing of the proposed device. This includes Archimedean screw design, angle of inclination of the turbine, overall length of the device, cost and properties of the needed materials. Number 2. Designing. Upon analyzing the gathered information and ideas, the researchers will now start in designing the needed components of the proposed device. Several factors will be considered in the designing of the proposed device. This includes Archimedean screw design, angle of inclination of the turbine, overall length of the device, cost and properties of the needed materials. Number 3. Fabrication. In this phase, the researchers will now gather all the designs and other concerns to properly construct the different components of the proposed device. This includes construction of Archimedean screw turbine, generator casing, screw turbine casing, and other more. Upon fabrication, different equipment and tools will be used to construct and assemble the proposed device. Number 4. Testing. The researchers will conduct a series of tests to the finished device for its evaluation and to test its functionality. The results of the test and evaluation will be analyzed to be used in succeeding procedure and modification. Initial testing. The researchers will be conducting series of tests to the proposed device to analyze and determine its effectiveness. Some important factors to be monitored are Archimedean screw turbine rotation and voltage output. Modification. In this section, upon completing the initial testing of the proposed device, different modification might take place to further improve and meet the total functionality of the device. Final testing. In this section, the researchers will be running further tests and evaluation upon completing the initial testing and modification of the proposed device. This is to assure that the device is functional and achieved or meet the researchers' goal and requirements.
Expected output. The expected output of this study is presented in block diagram below to properly show how the device will operate. Figure 6 shows below is the block diagram of this study. The first step is to get potential energy from flowing water. The screw turbine is then rotated by the potential energy, and the energy is gathered by the generator, and finally, it is stored in the battery.
Target beneficiaries. This study aims to promote finding alternative sources of electricity through innovative ways. Upon completing this said study, the researchers believe that it will be beneficial to the community. The proposed device can help community to at least lessen their consumption and electricity by using the potential energy coming from flowing water to generate electricity. Student, the research proposal can serve as a guide to student instructors on their selected research study that is connected to this present study. Future researchers, this serves as a related study to fellow researchers in the proposal output. Community, this study will help a lot in the community in having cost and also in environmental eco-friendly. School, this study can help schools to promote eco-friendly community and a step towards innovative thinking that might help their respective students in finding ways in saving the environment.